So to move on with this construction part, before that, let us introduce this introduction of induction motor. So we know electric motor which operates on AC supply is called AC motor. So AC supply is commonly available. The AC motors are very popularly used in practice. So AC motors are classified as single and three phase motors. Normally we come up with induction motors and synchronous motors. Synchronous motors we're going to discuss in the coming up topic, and some special purpose motors which is not included for your syllabus. So out of all these types, three phase induction motors are widely used for various industrial applications where you need require in change in torque and speed. We come up with the induction motors. And the important advantages of these three-phase induction motors over other types are they are self-starting. So they need not to have a starting device like we have for synchronous generator. We use a prime mover at the time of starting. So we have better speed regulations, and the construction is also very robust. When you come up with the construction part, we have two types of or sorry, two parts, that is stator and rotor. So the stator is a stationary part which is mounted on the floor, and the rotor is kept inside between some gap of stator. So coming to the stator part, it is stationary part as I said. Stator core is made up of stampings with thin laminations would be. So the thin laminations would be zero point 0.3 to 0.35 mm for smaller, and 1 to 1.5 mm for higher power machine. So it consists of slots where the armature windings are placed in the slots. The windings are connected to three-phase supply. Once it is connected to three-phase supply, the current flows and the flux is produced, and the flux is of rotating magnetic field. So it is of rotating. So that rotating speed of the flux is given by ns, that is 120 f by p, which where the p is the pole which determines the speed of the rotating magnetic field. When you come to the part of rotor, there are two types of rotor construction in induction motor. One is squirrel cage rotor, and another one is space bound or slip ring rotor. So normally we come up with the squirrel cage motor. So the comparison would be discussed later. So let us go with the construction of squirrel cage rotor. These are cylindrical and slotted in its periphery, and the rotor consists of uninsulated copper or aluminum bars called rotor conductors. The bars are placed in the slots. These bars are permanently shorted at both the ends. If you see that they are skewed at the ends, that means we cannot add any external resistance into the rotor circuit. So the entire structure is like a cage, so forming a closed electrical circuit. So the rotor is called squirrel cage rotor. So construction is as shown in the figure. So very strong in construction and rugged construction, long lasting. 90% of motor we employ is of this squirrel cage rotor. So rotor is of laminated core. So the rotor itself is short circuited. As I said, we cannot add an external resistances. Hence the construction is of this rotor type is very simple, and we oftenly use this type of squirrel cage rotor or squirrel cage rotor induction motors. And if you look at, there is a squaring. The rods, the conductor rods are slightly slanted, and it is fixed towards each end, both the ends. If you observe, this is called arrangement called squaring. So, what is the advantage of this squaring is by placing the conductors in this parallel to the shaft, the magnetic hum noise gets reduced due to squeaking. Hence, squeaking makes the motor operation quieter. So it makes the motor operation smooth. The stator and rotor teeth may get magnetically locked. Such a tendency of magnetic locking gets reduced due to squeaking. So it increases the effective transformation ratio between stator and rotor. So this is the construction. It exactly looks like a squirrel cage. So that is why it is called squirrel cage rotor. So next we come up with another type of rotor, that is slip ring or face wound rotor. So in this type of construction, rotor winding is exactly similar to the stator. So the rotor carries a three-phase star or delta connected distributed winding wound for same number of poles as that of stator. The rotor construction is laminated and slotted. The slots contain the rotor winding. The three ends of three-phase winding available after connecting the winding in star or delta are permanently connected to the slip rings. So with the help of slip rings, the external resistances can be added in series to each of the face of the rotor winding. So this arrangement is as shown here. If you observe here, the external resistance is connected, starting rheostat is connected to each face of the rotor. So at the running condition, this external resistance will be connected to the face of the rotor in star form, whereas during the normal running condition, it would be connected to delta. So the way the rotor resistance per phase can be controlled, some of the important characteristics like torque and speed. So by adding the external resistances. So in running condition, the slips are shorted. The possibility of addition of external resistance in series with the rotor with the help of the slip rings is the main feature of this type of rotor. So the whole resistance is included at the starting to limit the initial starting current, inrush current, because normally induction motor without load draws more current, that is 5 to 8 times of the normal current, which might damage the induction motor because it is short circuited sometimes, or it can damage the supply connected to the induction or the devices connected to the induction motor. So whole resistance is included at starting, and gradually once the induction motor picks up the speed, it is gradually the resistance is cut off, and it is when the 80% of the speed is achieved, so the rheostat will be cut off and the motor are short circuited, winding motor rotor windings are short circuited. So main the face mount rotor or a slip ring rotor is, they are higher cost because of additional resistance. Maintenance is more. Slip ring induction motor employed only in case of speed control. Then high starting torque is required. When it comes to the working of operation of induction motor works on the principle of electromagnetic induction. So when a three-phase supply is given to the three-phase stator winding, a rotating magnetic field is produced at a magnetic field is produced, and the speed of rotating magnetic field is ns is equal to 120 f by p, that is the speed of the rotating magnetic field. So this produce an effect of rotating poles around a rotor. So like the direction of the rotation of the rotating magnetic field is clockwise. For example, if you observe here, if this is the pole, south pole, and there is a flux between the north pole and south pole, this is the flux, and let us place the conductor, here. So we have the flux around the conductor also. So there is some of the flux which is parallel to the flux between the main field, so it might add up the conductors which are the flux direction, it is between north to south poles. Let us say it is in this direction. So let us assume there is a flux, in this direction. So the flux that is flowing from the direction is between north to south pole, and this is the conductor in blue. So some of the fluxes here, in the same direction gets add up. So when it comes to this direction, the flux here is in the opposite to this flux. So that is the main flux. So here it is getting cancelled. So that is negative, that is zero. So some of the flux adding up to the right side is zero, and towards the left side it is adding up of the fluxes. So when it is adding up, there is an interaction of two fluxes, that is the main flux and the conductor field flux. So what we call this, the cancellation of two flux on the rotor will not have any EMF induced in the conductor. Only when there is an addition of fluxes, there will be an EMF induced here. So the cause of rotor current. So when EMF is induced in the rotor, there is a rotor current which is flowing in the rotor. So this rotor current will oppose the relative motion to reduce the relative speed. So the relative speed is given as ns minus n. So this is the relative speed of the rotor. So the rotor always rotate in the same direction as that of the rotating magnetic field. If you observe, it is addition of this. So the rotor has to rotate when there is a combination of the fluxes. There would be a force exerted on the conductor to rotate in the in the clockwise direction. So that is how the rotor rotates in the direction of the rotating magnetic field. So can we have n is equal to ns? See, when if the rotor catches up the same speed of synchronous speed, then the relative speed is zero. That means eventually the motor will stop. So always n should be less than ns. So since it is less than ns, we call this as subsynchronous speed of the rotor. So n is the subsynchronous speed of the rotor, and ns is the synchronous speed of the rotor. So review questions: explain the construction of three-phase induction motor, where we explained about a stator and rotor, different types of rotor, that is squirrel cage and phase wound rotor. And we also discussed about the operation principle, or a principle of operation of the induction motor. So which type of rotor is most widely used in induction motor? Is squirrel cage, because it is cheaper in cost and maintenance is easy. The rotor slots are slightly skewed in squirrel cage to increase the rotor bar strength, prevent cogging effect. So both of the above.